Hey guys, so we're back here with the third installment of the grass growing tutorial. And sorry, I just want to apologize in advance. I've been sick all week and I'm still getting over my sickness, so my voice is kind of crappy and I'm probably going to cough a lot, but I want to do this anyway. So here we go. We're going to be learning how to make this, which is sort of the third method of making grass growing, which is we're going to be doing this in actually simulating it in Vellum. So you can have it grow and then you can have it be fully dynamic. So you can have colliders like this ball here. But yeah, so let's get started. Let's put down a geo, call it grass, and we'll put down a grid and leave it at the default. And then let's give it a normal because we want normals pointing upward because we're going to scatter some stuff onto it to make it into grass. And then let's put down a scatter and let's make the count like a lot more for now. We can make this more later. And then let's copy a line to it. So we will do a copy to points, and oops, we'll put points there, and we'll put a line down and put this in here. And of course our line needs to be aligned in the Z plus direction like this. And let's make the line let's give it a length of 1.5. And right now it only has 2 points. Let's give it 9 points. Okay, cool. So there we go. There's our grass. We're done. No, so there's a few other things we need to do to kind of make this feel better. I guess the first thing we can do is let's adjust the p-scale. So let's put down an attribute adjust float right after the scatter, and everything disappears because there's a constant value of 0. It's defaulted to p-scale. We want to put set initial, and let's set this to noise. And then what we can do is we can adjust the minimum and maximum. So we want like some that are like 1, some that are not quite that, and then we'll have maybe make the element size bigger. So some of the blades of grass are going to be shorter, some are going to be longer. Can't really see it all that well right now, but you kind of, just because the way it's being displayed. Okay. And then we also want to randomize the color a little bit. So let's put down an attrib adjust float again. And this time we're going to call this color. Okay. And for now we can't see anything, but let's flick this on so we can see it. Let's do let's do set initial, and we'll set it to random. Random. Okay. Cool. Now that's not really what we want right now, but what we can do is after the copy the points, we can put down a color node, and we can do color type ramp from attribute, and the attribute will be color. And then we can change this here to be like this one can be sort of a, I don't know, palish green. And this one can be, here, let's click this on so we can actually see it. And this one can be more like a true green, but darker. Something like that. Maybe a little more yellow. Cool. So now we have sort of a more of a grass color. Great. But these are all very straight. I want them to be kind of bent a little bit and randomized. And a really cool way to do that is to put down, use some of the hair tools. So we can use a guide process, bend. Okay, so if we plug that in, it does absolutely nothing. So what we want to do is change the mode from bend in root direction to direction curve attribute, which is this one. And it's going to be expecting an attribute called bend_dir, which we don't have yet. So what we want to do is we want to set that up. And so we'll just do an attribute adjust vector is what we want, attribute adjust vector. And the attribute we want is bend_dir. like that. And then what we can do is we can do direction and length. Yep. And we'll do set initial or set always, one of those. And then we'll do adjust with random. And it's still not doing exactly what I want. Let's see. Amplitude 1. Oh yeah, so in this axis computation, you have to change it from cross product of skin normal and direction to cross product of root, tangent, and direction. There we go. So now they're all bent a little bit in sort of random directions. Now you can see they're kind of bent, they're all kind of like going the same way. So what we want to do in this attribute adjust vector is change this to from positive to 0 centered. And then it's like truly random. And we can change the amplitude a little bit. We can change the seed. And then in the guide process bend, we can, of course, bend it more, bend it less. I think just the default is kind of fine. You can do random angles. Maybe make it a little bit more random. But yeah, so there. Now we have a little bit more random looking grass using some of the hair tools. That's nice. Okay, so the other thing we want to do is we want to make a group here on the line, and we're going to call this root, and we want this to be a point group, and the base group should be 0. So that's just the very first point. So we're going to use that to pin it down in our Vellum simulation. Okay. Okay, cool. So the next thing we want to do is put this into a Vellum hair simulation, or Vellum configure hair, and then Vellum solver. Cool. So under the Vellum hair, let's put the pin points or pin to animation. That'll be our root group that we just created. Make sure it's permanent. And then under the stretch stiffness, bend stiffness, I think we can leave those mostly at default. Maybe the bend stiffness, we probably need to bring it. Well, let's just leave it at default for now. And then the last thing, let's see. Let's just hit play and see what happens. So they all fall, but you can see they are being pinned in place by that bottom point, which is great. So it is working. Okay. Something we're going to want to do is probably turn on ground position here. So let's hit that again. Now they all fall. They collide with the ground. Great. Okay, so that's fine. But I don't want them to fall, and I also want them to grow from nothing. So first thing probably is to maybe adjust the stiffness here. So under the bend stiffness, maybe we'll make this go up like 2 decimal points there, and let's see if that works. Just give it just enough to support itself. That's pretty good. Yeah, maybe something like that. So it could still be kind of affected by wind and stuff, but it's not just falling over completely. Okay, so how do we get this to grow? Well, the easiest way to do that is to animate the rest length. So, and the easiest way to animate the rest length is with a Vellum constraint properties. And this is always confusing to me, but what you don't want to animate rest length, even though you are animating the rest length, you want to animate the rest length scale. And if you just put this down to 0 at the beginning, like if I just hit this down to 0, it's going to just like freak out and like, well, maybe not. Maybe it just does nothing. Oh, it's because I think I need to put in bend and stretch. Let's just see. Still nothing. Weird. But anyway, let's try animating this down. So if I do this. Let me click this little brain on so that it doesn't calculate. Let's come out to like frame 24, bring this down to 0.001, and then have it kind of hold there for a few frames. And then from there, come up to like frame 72 and bring this back up to 1. And let's see what that does. Let's click this, get that guy, and then that is so strange that it's not doing anything. Let me come out and see if that, oh yeah, there. So I wasn't seeing it because I'm not it. Okay, so it grows down and then grows back up. Okay, cool. So that works. So you can see animating rest scale is working. But what if I don't want it to grow uniformly like that? What if I want it to start at one side and go to the other side, or kind of start in the middle and go outwards? How would we do that? Well, let's use a MOPS fall off for that. So we're going to come back up, and right after the scatter, we'll put a MOPS shape fall off here. And let me, it's weird. Why is it stuck on this stupid viewport? There. Okay, and let's do preview fall off. And I think maybe I want like a sphere, because I want it to have a start in the middle and go out. So we'll bring it down to like this, something really small. You can't go down to a 0, just something really small. And then let's animate it outwards. Or actually, you know what? I'm wrong here. So what I want to do, this first MOPS, we're going to do 2 MOPS fall-offs. So the first MOPS fall-off is going to be us animating the size of the grass from 1 down to 0. Because you can't, it freaks out if you just have it go straight to 0 on the first frame. So you kind of need to give it a little bit of a head start for a few frames to have it animate down to 0 and then grow back up from 0. So this first MOPS shape fall-off, we're going to do a linear shape. And I was wrong about this. Let's delete this guy. Let's make it a little larger like that. And we will have it translate. So let's have it start here. So this will be, everything is at 1 like that. And so let's hit play. Let's go to like frame 48. The slower you can go, the better, the faster, the easier that Vellum will have, will calculate with less sub steps. Okay, so let's just hit enter on the keyboard. Why am I doing it like this? And bring it over here. So that'll be 0. So let's just check if this, how can we get this to work? How can we bring this in to affect our constraint property thing here? So if I go into this, I want to go use Vex expressions, and I want to, let's make a little null here. We're going to call this mask. Okay, and what I want to do is in our Vellum constraint properties, under inputs, under input 3, let's do SOP, and then we'll use mask. And then under Vex expressions, I'm just going to use a point function. So we're going to go float mask equals point. And this is a very common one I use all the time to just basically pull in the data from points. And the geometry number is 2 because we just set our input number 2. I know this is so confusing because they have input 1, input 2, input 3, and input 4. But really it's input 0, 1, and then 2, which is the one we're using. I don't know why they label them as 1, 2, 3, and 4 when we always use 0, 1, 2, 3. It's super confusing that way, but you just have to remember input 1 is always 0 in stupid computer language. So even though we're input 3, technically it's 0, 1, 2. So we are input 2. That's the one we're trying to pull the data from. And the data we want to pull is MOPS fall off, and then at ptnum, just for every number. Okay, so we now have our float called mask, which is equal to the MOPS fall off that we have. And then what we want to do, let's delete this because I don't actually want to animate this anymore. I just want to say rest scale equals mask or mops fall off. It's the same thing. So let's hit play. So you can see it starts at one end and goes down to the other. So it's working. Great. Okay. So that's our like scaling down. And now we want it to scale back up. Okay. So for that, I want to use a mops spread fall off. I like that one a lot. It kind of gives me, it's almost like an infection solver, but I don't know, better. So, okay, we've got this working. But let's make a group here. I want this to be procedural. The mops spread fall off takes a point. You could just select a point, but if you change your point numbers, which we're going to do in a little bit, it doesn't work. So let's make a group called strt, and this will be a point group. And let's just do keep in bounding regions, and we'll make bounding sphere, and we'll make it really small like this. Okay, so the mops spread fall off we'll use our start point group, and then let's do preview fall off. Now, if I just leave it at the default, it's going to override my original shape fall off. I don't want that. I need both. So I'm going to set the blend mode to add. So that way we still have this old one, but I also can animate this this new one on top of it. Okay? So I want it to go all the way to 0 here, and then maybe around frame, I don't know, 72. Let's have the spread fall off, go from 0, and then we'll animate it all the way to like frame, I don't know, let's go like frame 168 and animate it up all the way out like that. And then I can adjust this a little bit. I don't want this to be completely linear. It's like very circular. And the fall off width is too small, is too large. I want it to be a little more gradual, something like that. Seems pretty good. Maybe let's bring this out a little more. And then let's bring the spread out so it goes all the way. And then maybe let's add some noise. Could do apply noise. And maybe if I make the background dark, it'll be a little bit easier to see. Yeah, that's better. Let's add some noise. Let's do maybe higher frequencies. No. Maybe just some low frequency noise. Something like that. So it's a little more natural, maybe a little higher frequency. We can change this to like curl. Cool. We can start with that and see how that looks. We can adjust it later. So now if we look, we've got our scale down and then the scale up. Okay? And it's all called mops fall off. And we can turn this off. Let's come back down here. Why is this throwing up an error? Duplicate point ID attributes detected. Ah, yes. Okay. So if you do choose to use this mops spread fall off modifier, it does automatically add an ID attribute, which Vellum does not like. It wants to add its own. So we want to put down an attribute delete here and just delete the ID. And that should, there we go, that fixes it. Okay, and now if I hit play, let's see what happens. Okay, everything scales down. And here's where it starts to scale up. Let's see how that looks. There we go. It's working. So, and it's fully dynamic too. So because this is Vellum, we can add in like pop wind, we can add in colliders, okay? So before we add in like the wind and the colliders and stuff, I want to address an issue here. So right now, obviously, we want this to grow up from nothing. I'm having this scale down, but they don't delete. They just turn into these stupid little curly pubes. Nobody wants those curly pubes. Let's delete them. So the way to get rid of them, there's a few ways we can do it. Basically, what I want to do is I want to measure the Y height. So I can do like, or I could do a group expression. We'll do group expression. And I want this to be a primitive group. We're going to call it pubes. And then we will do at p.y if is less than 0.05. Let's just start there. So basically what that's going to do is if the y height is less than this, it's going to put it into a group. So let's put this down and we'll see if it groups these guys. So you can see as they get really low to the ground, they get put into a group. And maybe we can make this 0.04. And it's not getting all of them. Let's see. Yeah. Okay. So then it puts that in a group. Then what we can do is we can just put down a blast and we will blast away the pubes, leaving only the rest of them. So now, as I hit play, and they should appear once they start to grow back up again. This obviously is not in real time, but you can see it's working. Great. Okay. So that is that's the basis of the effect. Now, the other thing you could do, if you were doing this, right now we're doing this on a flat plane. So this p.y works really well. The other thing you could do, if you were copying these onto like a sphere or something, or some other topology that isn't perfectly flat, the p.y function might not work because they might not all be pointed up in the y direction. So you could put down a measure and measure the perimeter, and then look at your attributes here. Oh, that would be, it's this attribute, perim, right? It's a primitive attribute. Do we not have it? Strange. Why is this not giving me? So I do have perimeter. Oh, right here. Okay. But you could see, your smallest ones are like 0.2, your largest ones are 1.4, and you could just say something like, for your group expression, instead of at p.y, you could just say at perimeter is less than, and then whatever number you want. Okay, the next thing to do is maybe let's add in a little bit of wind to kind of make this feel a little bit more natural. So let's come back in here. We'll do pop wind. And maybe let's have this activate at like frame 72. So I don't really want it to be windy while they're scaling down. I just need it to be windy when they're kind of scaling up again. And let's give this an amplitude of like 0.6. Maybe let's turn on the guide so we can see these little red lines here, kind of show us what we're dealing with. The swirl size, let's make it a little larger. Maybe like, 2.3. The swirl scale, let's bring that up a bit. 1 point, something like that. And then maybe make the pulse length 1.5 or something like that. Or maybe 0.8. I don't know. Okay. And then I kind of just want it to have sort of a gentle breeze. I don't want this to be like super turbulent. I just want it to kind of blow gently in the wind. And then the next thing I want to do is let's add in a collider. So let's just put down a sphere. And let's bring this, make it larger, like this. Let's bring it up, like that. And then let's bring it over here. Let's hit spacebar 3 on the keyboard. I want to make sure that this does not go lower than the grass here. Let's make it like here. Bring it on over. Yeah, that seems right. That's weird. Why did it? Yeah, something like that. Over here. Cool. And then let's make it, instead of a polygon mesh, let's make it polygon. Give it a frequency of 20. And then put down a transform. Like that. And we'll do move centroid to origin. And then control middle mouse click to put it back where it was. And then we'll animate this. So let's turn off the brain so that this doesn't simulate. We'll come out to frame 72. Or maybe let's come out to like maybe frame 120, because I want this grass to kind of grow on first before this thing starts rolling across it. So from frame 120, we want to animate the Z. Okay. And then come all the way over to here. And let's animate it across. Something like that. And then let's animate the rotation too. Maybe I'm just kind of eyeball this. Maybe like this. And then we'll do like, say like minus 300. And we'll see what that looks like. Yeah, close enough. It's probably not super physically accurate with how it would roll, but it looks decent enough. Okay, and then all we need to do to get that to work with Vellum is just plug it into this third input here, and it automatically becomes a collider. So if I come right here, kind of set up my camera, or set up a camera here, and I'll just kick off a render view, or a flipbook, and see what that looks like. Okay, so I've got my little flipbook here. We can take a look at what it did. So, got the scale down, and then everything starts to scale up. Cool. And then you can see the ball roll across it. So it's working. You can see the collider is working. Although it's not enabled, you can't see the visibility of it, but you can see what it's doing. But I want the grass to like stay down and create a path like where it's behind where the ball is rolled. So right now it's like it's going down and then it's sort of like popping back up. And then the other thing I want to do, I don't really like the way that this noise pattern looks. Maybe it's like, I don't know, maybe it's too noisy or something. I kind of want it to be a little more circular, a little more contained to the middle. Okay, so let's adjust that. So what I'll do, I'll come back up to my spread fall off here. And let's take a look at that. Let's take the amplitude way down. Something like that should be better, right? Probably. Okay. And then maybe I want I think maybe my fall off width to be a little less gradual. Okay. And then I probably want a lot more lines. So instead of having like 10,000 of these, let's give it like 30,000. So change that to a 3. Okay. And then the other thing, the way to get grass to stay down is under Vellum Hair, under the, where is it? Come on. Right here, under Bend, there's this little box called Enable Plasticity. Just click that. And you can play around with this stuff here. I'm not exactly sure, how this kind of basically makes it like more hard or less hard. But basically by enabling plasticity, it's going to kind of stay matted down. So that's all you need to do. Let's come back here and then let's run another flipbook and I will show you the result in a second. Okay, so we've got our new render here with a lot more grass. There we go. There's the scale down and the scale up. A little better than before, I think. and then you can see the grass stays down. Cool. So that is pretty much how you would do the effect. And of course, you can refine the timing of everything, refine the masks, but that's pretty much it. So I'm going to cache this out, and I'm going to show you guys how to render these grass things in Redshift. So let's put down a just a Vellum IO right here. Call this grass Patreon. And why is this giving me an error? Not enough sources specified. What are you talking about? Because I need to plug in all three. Of course. And then let's just hit save the disk and come back here in a sec when this is cached. Okay, got this thing cached. Great, it's working. Awesome. So let's render this thing out. And we set up a light and stuff, and I'll kind of show you how to render it out. Let's put down a grid just so we have some sort of floor. We'll call this BG. Let's make it much larger. Let's do like 3. And then let's put down a RS dome light. And we can use something like, I don't know, I'm just using like a grayscale gorilla one. I'll use this Studio, HDRI Studio Volume 2, something like that. And then let's put down a camera. Let's put down a null. Parent the camera to the null. Let's jump into the camera. Pull it back out in Z a lot. And then come back to the null. Just rotate this guy. So we're kind of looking at it. Something like that. Okay. And then let's just fire it up and see what we get. Well, actually, what we need to do first, under grass, we'll go to the Redshift OBJ tab, and then under strands, render objects as strands, and let's put it as capsus, and just leave it at the default, and just see what happens. Okay, so not quite grass-like, but still cool. We're getting something. Looks more like underwater coral or something like that, which this could be used as like a growing underwater coral effect for sure. But how do I make it look more like grass? Well, first let's, oh shit, crash, no. Oh, fuck off. Okay, so we're back to this. Cool. So let's desaturate this light a little bit. I don't really want it to be blue. And then how do I want these grass blades to be thinner at the top and thicker at the bottom. And then also they're all the same size. The ones at the edges should be smaller than the one, or like thinner than the ones at the fully grown height. So how do I do that? Well, this grass, this like Redshift OBJ strands thing, uses p-scale as its way to scale these up. So if we manipulate the p-scale of these, we can manipulate how they look as grass. So let's do that. So let's put down, we're going to put down a resample. So let's first address, we're going to first address making these thinner at the tips than they are at the base. And then we'll secondly address making the edges, the leading edge, be smaller. So let's put down this resample. We don't actually need to do any resampling. All I just want is this curve view attribute. And then what I want to do is put down a wrangle and say at p-scale times equals at curve u. So curve u, remember, gives us this fall off from 0 to 1. 0 at the base, 1 at the tip. So basically we're multiplying, we already have p-scale, we're multiplying p-scale times this. So it's going to be thin at the bottom and thick at the top, I think. We'll probably need to invert this, but let's see. Let's just see what it does. It looks like it's working. So yeah, the thin at the bottom, thick at the top, which kind of looks cool, but that's not what we want. We want the opposite of that. So what we can do is put down attrib remap, attribute remap. God damn it. Come on, attribute remap. There we go. And curve U is what we want to remap. And let's make this go the opposite direction. So that basically just inverts it. But then what we can also do is we can finesse the shape of this. So instead of this just being linear, we can make this feel a little bit more organic by changing it to something like B-spline, B-spline, and then put this here so that it kind of stays mostly thick until the end and then drops off. Now let's see what that does. Nothing. Interesting. Oh, that's because I have misspelled curve U like an idiot. Curve U. Now, there we go. So we're getting exactly what we want. And so now we have control over, maybe we bring this back a bit, and that's going to adjust how this looks. So thick at the bottom, thin at the top. Cool. So that looks a lot more grass-like automatically. Okay. Now the other issue is it looks pretty unrealistic to have all of this leading edge still be that thick. So what can I do to make the leading edge be thinner and then they scale up to their full thickness as they scale up to their full height? Well, remember we have that MOPS falloff attribute and going from 0 to 1. I don't think it comes through the Vellum solver automatically. I think if I hover over this, let me see. If I click on MOPS falloff, yeah, for some reason, it's just like, it doesn't do the right thing. So we just need to put down a attribute copy. And we do it here. And what I want to copy, let's bring this mask. So from up here, and the attribute I want to copy is MOPS falloff. Now, if I, click on this, hover over it, and click MOPS falloff, there we go. So now we have this 0 to 1 attribute, which we can use. So remember, this part is 1, this part is 0, so I can use that as a multiplier. So let's do, let's go back down to this thing here. And right after this, we'll just do another at pscale times equals at MOPS falloff. So that will basically be, the edges will be 0 in thickness and the center will be 1 in thickness. So let's fire this up again. There, problem solved. Cool. So that kind of gives us our shape of the grass. Now, how do we get our color in here? Let's kind of light this and shade this and make this a little more beautiful. So let's come out to here. Let's come out to a frame where the thing's fully grown and we can kind of see it better. Something like this. And let's maybe put down an RS light and change this to spot, temperature, and then let's put down a null. Oh, shit. Come on. Null. Call it target. And then the light, we will, under transform, look at options. We'll use this as, use this as the target. So now when I take this, it will always point at the target. Okay, let's do something like, let's bring it off to the side. And maybe let's bring a target up a bit. Okay, let's go back into our camera. And let's fire up the render view again and see what we get. And I think I want to rotate my camera. I don't like seeing directly down the center of this thing here. So let's, oops, minus 27. I think that was correct. And then let's do like 45 here. Something like that. Let's even move this up like this. And let's maybe make the focal length of our camera a little more. So, okay, let's kind of adjust this more. Let's maybe make this like 80. Why is that not doing anything? Oh, there we go. It did. Maybe bring the Z out here, transform it back in Z a little more. Something like this. Maybe bring this, I don't know, so we can see it cross it a little more. Sure, something like that for now. And then let's come out. Oh, I liked it. Let's also make this be, go to optical, filmic, bring the exposure down a bit. And the RS light, I want it to be temperature and make it a little warmer, something like that. And let's bring the exposure way up. Let's bring the cone angle down so we can kind of see where it's affecting. The fall off angle like this. Maybe let's kind of move it around a bit. Something like that. I don't know. Seems decent. Maybe let's bring intensity down a bit. Okay, so cool. So we have this like white grass. How do we make it not white? Well, under grass, let's go render, material. Let's type in /matte/grass, which is a material that has not been created yet. So it's not going to do anything. But if we hit this little arrow, it'll take us to our material context. We can put down an RS material builder. We'll call it grass. And what I want to do is put down an RS point attribute, because remember, we already set up a color for this. We already kind of made this random green thing. So if we just pipe this in and hit refresh, it should give us some green grass. All right, that's cool. So let's also give it some subsurface scattering here. Let's bring this up. Let's bring the scale down. And let's plug this into the color, to the MS color. .001, .003, something like that. And we can even put down a color correct here. And if we template this here, maybe make it a little bit more yellow, so that the light shining through, yeah, something like that. Seems a little better. Maybe let's make the weight higher and the scale lower. Okay, cool. Something else I want to do is let's adjust the lighting a bit. Let's go back to our OBJ view. So now that this is green, we probably need to bump up the intensity here a little bit so we can actually see everything. I don't know, something like that. Cool. Usually grass, if you ever look at it really close, it starts off like at the base is kind of white and then the tips are more green. So remember, we have that curve U attribute, which we can use. So we can bring in a curve U and we can put down a color mix. So color mix like this, and then like this. Sever this guy, put that in there. And we'll use the curve U as the mix amount. And if we hit refresh, there we go. So we're mixing in white. And so the white is sort of at the bottom, and then it's more kind of grassy at the top. And of course, we could put down a ramp here in between these two and kind of adjust how harsh that transition is. So we can make it like this. So it's really harsh, so it's almost like painted. We could have it be like almost all white if you want. Actually, losing my voice a little bit here. I liked it the way it was. Maybe just bring it down a bit so the tips are still more green. But that's looking pretty realistic. We could also, we could change this to something else. It doesn't need to be white. It could be something like, pink. So that it's like as this ball rolls through It sort of reveals the sort of pink underside of it. But I like the white for now. I think that's the more realistic way. Cool. I think that's mostly it, right? Yeah, I mean, just play around with the subsurface a little bit. Maybe make it more. You could play around with the reflection roughness, make it a little more rough, something like that. Of course, you could play around with the thickness of the grass. You could make it thinner or thicker. You could make more blades, less blades. Something else we probably want to do is if we want to actually see this ball, let's put a null here, call it ball, and then copy it, come up, put down a geo, name it ball, put down an object merge, throw that guy in there, and then now we have our ball. And then of course, we can maybe let's put down before the transform, let's put down a UV unwrap. And if we come up on the ball, we can do render /matte /ball, and then make a material for that too. Oh, gotta name it the right thing. And let's kind of come back a few frames so the ball is more in the center. Hit render that. Oh. Maybe like here. Okay, cool. It's better. And then let's make this like, I don't know, make it like a gold or something. Oh, that's kind of cool. And then you could, of course, give it a texture. Let's put down an RS texture. And in our OD asset library, maybe put down like give it some like scratches or smudges or something like that. So maybe I'll do like smudges and grab this guy here and plug it into the reflection roughness. Let's refresh it so I can see. Of course, I need to make it be raw. And then, I don't know, something like that. Just a little bit. And then, of course, this is like blindingly white right here. So I'll probably want to, in my camera, come to the color correction and do tone mapping and bring the highlights way down so they're not like blown out like that. That seems to help. And then on this background, let's put a UV texture as well. And then under render, let's go /matte /bg. And you could make this be, put down a RS material builder, call it BG, and make this be whatever color you want. Maybe make it a little darker, make the reflection roughness, I don't know, something like that. So it doesn't reflect as much light from underneath. Cool. That's pretty much it. I think that's it. I think all I did was add some DOF in here. Like I centered my camera up a little bit, kind of figured out the best point of, where, so I'm not really seeing the edges. And then just put in like put some bokeh on there. So let's just select this guy, bring this way down, and compensate for it in the exposure. Make it feel kind of small. Something like that. That's pretty much all I did. So I think this is a pretty simple effect. Once again, you're just copying lines to a grid, and then we're just adjusting the rest length scale with a MOPS falloff. That's it. You can get it to grow. It's fully dynamic. It doesn't have to be, I just gave you a very simple example on a flat grid, but you can have this grow across any sort of 3D surface. And it doesn't have to be grass. You could make it be like like tendrils like we had originally. It could look like underwater coral, or you could use a path deform and, copy a bunch of like models of flowers onto this or something so that the flowers actually look like they're growing. So yeah, that's it. I hope you enjoyed this. Let me know if you guys have any questions in the comments, and I'll see you in the next video.